Well, hello, NATR 346. This is a medium length talk about module number 11 here, which is about the infrastructure in California's water systems, including the Delta. So, in this module, you'll see an overview of the Central Valley Project and the State Water Project. That's basically what I mean by infrastructure, and that's what I want to talk about in this talk. And then later there'll be an introduction to the Delta. So if you look at the infrastructure unit, there's just a write-up here with the lecture notes that I'm going to talk off of today. And then I also introduced this, I think, a very good lecture. It's about 20 minutes from a professor at UC Davis that provides a similar overview but emphasizes different things. And then there is a 12 question quiz on all this stuff, of course. No problems. There's a mapping exercise we'll go over. And then optionally, there's a really cool video that Maven's Notebook put out. So if you go to this site, go to Maven's Notebook, or I'll just do it now. It does a neat flyover of the State Water Project, and it's just music and literally aerial views of all the features of the State Project. With the nice music, it makes you feel like dams are just wonderful things, but that's what it is. It's a neat thing to look at after you look at the maps, and it gives you a different feel for all these different features, because the State Water Project is truly a marvel of engineering. And it's really worth checking out and getting to know a little bit. So for this talk, let me pull it up here. Let's see. And yeah, I'll just go over a quick overview. What I want you to get out of this is just a basic understanding of the difference between the State Water Project, the Central Valley Project, and then major local projects. So like the talk that Professor Lund gives, we start with this map of California. This one on the left is kind of has drainages exaggerated. It doesn't let you know that the north is wet and the south is dry. These rivers down here in southern San Joaquin Valley are mostly dry now. This map on the right is the distribution of rainfall. And again, Professor Lund goes into that in more detail, but this is just, you can see here the stark reality. Blue is lots of rain, red is no rain. And because our state is, maybe 600 or 700 miles oriented in a north-south direction, we have wildly different climates in California. And there's like this 80-20 rule, or 75-25 rule, basically, that 80% of the rain falls in Northern California and 80% of the demand for water is in Southern California. So basically, these big water projects move water from the north to the south. That's about all there is to it. It's kind of like Water 1.0. These folks in LA and San Diego and the southern coast here need water to grow, or want water to grow anyway. And then more is this red area here in the southern San Joaquin Valley, which is a great place to grow food because it's warm and wonderful soils and long growing seasons, but it needs water. So in a nutshell, the Central Valley Project moves water from these blue areas to the San Joaquin Valley for agriculture. And the State Water Project moves this blue blob down to Southern California population. So again, in a nutshell, the Central Valley Project, about 75% of the Central Valley Project water goes to agriculture and 25% to urban. For the State Water Project, it's the other way around. Greater than 75% of the State Water Project water goes to people and the remainder to agriculture. So we'll go over that a couple of different times. And remember, up in here, there's some wild and scenic rivers. All this blue up here is not captured by our water system. Rather, we capture here with the Shasta area and up here, and the Feather River drainages we capture and distribute in this system. The history here is there's many books written about it, and some people really love to go into water history in California. It's fascinating. If you're interested, there's lots of books. For this little mini talk, I'll just mention briefly, kind of highlight the mindset that went into designing California's water system. Is really a turn of the century mindset. And it's really, to me, spelled out in this quote by this colonel of the Army Corps Engineers, that he did rough calculations like we do in class. How many acres of land are there available? 12 million acres in California of level land with good soils. I mean, that's an interesting estimate. This was before geographic information systems. And also tying it to the water, saying that there are each year snowmelt and rainfall goes through the Sacramento San Joaquin River Valley system and is unused, lost forever. Enough of that water could put 3 feet of water on all the available acres. I'm emphasizing the unused because that was the mindset. You know, if water falls from the sky and goes into a watershed and provides habitat for vegetation, avian corridors, recreation, obviously fisheries, that's unused. And so that really was the mindset of the agriculture economy. And, you know, this individual here actually did the preliminary design for the whole system. And look, obviously doesn't look like this, but just as a starting point, he had a dam down here. Here's Redding. The real Shasta Dam is, I believe, up here more, but you get the idea. And then just use canals to convey the water and basically deliver it from north to south. That's the concept. And that's basically, you know, in a crude sense of what these programs look like or what ended up happening. So this is a nice slide that just contrasts the two programs, the Central Valley Project versus the State Water Project. And it's important in California to know the difference. Central Valley Project is a federal government, United States federal government, funded and built that project and continues to run it. That's why we have so much federal involvement in our water. And the story, and it's not a rigorous history here, but in a nutshell, you know, around 1920, 1930, California was all into the Central Valley Project concept. We knew we wanted to build it. But we had the Great Depression, and states didn't have money for that kind of project, and so the federal government stepped in and built it for California, starting with Shasta Dam. And it's a combined water storage and hydroelectric plant. And then they went on and did Folsom Dam. That's another federal project. And they didn't build conveyances all the way from the dams down to farmland. Rather, they decided to use the rivers as conveyances. So you have Shasta Dam. They use the Sacramento River to deliver water from the Shasta Dam through the Delta, and then it's pumped out of the Delta and then down into the Central Valley. So the Central Valley Project has Shasta and Folsom and many other dams, and Friant Dam is another big one. Many other dams are all part of the Central Valley Project, designed mostly to get water from where it falls to the agricultural Central San Joaquin Valley, The State Water Project came along decades later, and that was more to satisfy demand for growing populations in Southern California. And so the key feature of the State Water Project is a dam at Lake Oroville. It's actually the tallest dam in North America. Check me on that. Oroville Dam is kind of a big, ugly earth dam. When you drive by, you can hardly tell it's there. Versus Hoover Dam, which is kind of a work of art, the concrete dam there. But I believe that the Oroville Dam is taller than the Hoover Dam. And if you've been at Hoover Dam, it's an amazing place to see. And the Oroville Dam is kind of an ugly, big lump of clay. But it holds back water from the Feather River drainage, uses the Feather River and the Sacramento River to deliver it to the Delta, pump out of the Delta, and go down. This is the famous feature of the California Aqueduct. This baby's 444 miles long, and it just shoots on down the valley, and then it gets pumped over this mountain range here, and then delivered to all these intermediate storage facilities, and then that gets delivered down to urban areas in Southern California. And so all these urban areas down here in Southern California rely heavily on water pumped out of the Delta, which is ultimately stored and saved in Lake Oroville. So I have included a couple of different maps from different publications to give you an overview of these systems. Federal, state, and local. You'll hear Dr. Lund talk about these different layers of government involved in our water. And this map kind of shows you the key features of the federal project. There's Shasta Lake, Folsom Lake, Millerton Lake. So these are the major federal part. That's the Central Valley Project, delivering down to the ag areas. The state water projects in blue, Lake Oroville is the biggie there, and the California Aqueduct. Look at this little offshoot going all the way down to Santa Barbara. Big projects here, moving water massively. I mean, in the scale of the globe, this thing is a giant, giant project. And then, not to be discounted, are the local projects. Famously, the Hetch Hetchy Reservoir, damming Hetch Hetchy Lake, damming that valley, and piping that water in these green lines directly to the Bay Area. Comanche is a little less known, but there it is in the Mokelumne Aqueduct. And then another famous one, LA, very thirsty, gets water from the California Aqueduct, from the State Water Project. It gets water from the Owens Valley. There's a long story about there, kind of sketchy, how LA bought all the land around Mono Lake and the Owens Valley for the water rights and took that water out of that valley and pipes it into LA, stunting any possibility of growth in this area to thrive. It leaves behind a beautiful area, though, I gotta say. And then LA also taps into the Colorado River. So they're just thirsty. They'll take it from anywhere. The Delta, the Colorado River, Lake Owens. And now more and more recycling and desalination, because LA and Southern California realize being dependent on the Delta is not a good thing for them. And we'll get into that with the Delta. We could have the big gulp. The whole supply could be compromised by a single earthquake. We're also fighting back more and more to get more environmental flows, and so less water allocated. So they're very motivated to be more self-sufficient, and they're doing a lot of great work to that end. So that's another view of these three major systems: State Water Project, Central Valley Project Federal, and then the big key local projects. Here's another map that is a nice kind of summary of these different projects to check out. And what I want you to be able to do here is, this is a map from a certain report by the Pacific Institute. And it tries to portray a lot of information on one figure. It's kind of a mess. The reservoirs are in triangles. Black is federal, green's local, red is state. And so what I want you to be able to do is find the major features of California on this sort of strange map. Let's see if I have that handy. Ooh, I don't. It's in the problem set. So what I have in the problem set is this weird map, and then a list of features like Lake Shasta. That's here. And so if you can find these features on this map, I think that's a good way to just kind of orient and study what these water systems are like. Here's the Owens Valley delivering water to LA. Here's the Colorado River, and here's the Colorado Aqueduct delivering water to Southern California, etc. So this is another nice diagram from a water handbook in California that gives a picture of how water is transferred in the state. And very schematic here. I don't even know if I'm going to ask you any questions about this diagram, but it's just a cool way to look at how water is being moved. The big kahuna here is taking water from Lake Shasta in the Sacramento area and moving it via the California Aqueduct to the south coast. That's a giant transfer 1,571 million acre feet down south. You can see the Trinity River taking a little of North Coast water into this Lake Shasta, but basically there's not much that leaves the North Coast. And here's the Frank Kern Canal down in Southern California delivering to Tulare Lake. It's just kind of an interesting way to get an idea of all the different water transfers that are going on. Very complicated system. I just, on this for illustration, pointed out the Hetch Hetchy Valley and that controversial reservoir that provides water directly from San Joaquin watershed, the Hetch Hetchy Aqueduct, to San Francisco Bay. You know, one of the reasons that is so controversial is, like I say, when the federal government dams water at Shasta Lake, they want to deliver that water to a farmer in Bakersfield, they use the Sacramento River. And while the water's in the Sacramento River, it's providing habitat, it's providing recreation. Some people are using it and discharging it. And so it's getting a lot of use along the way. When the dam at Hetch Hetchy was built and Mokelumne, see, these green lines are across California, so they couldn't use the natural gradient and lay of the land. And so they built these giant pipe aqueducts that pipe water directly to San Francisco. So San Francisco water is like snowmelt out of the Sierras. This water along this pipeline obviously doesn't get used along the way. So it's really a pretty wasteful way of trapping water and delivering it because you're not getting multiple uses out of it along the way. Kind of an interesting side point that people bring up because a lot of times, you know, environmental groups coming out of the Bay Area are saying how terrible all these dams are and how we need more environmental flows. And yet they're drinking water right out of a snowmelt pristine basin that was dammed up and filled up with water and piped directly to their spout. So it's kind of a little bit of a weakness in the argument there that they have, some people say. So the Delta, there's going to be a whole nother talk and problem set about the Delta because it's so important. Drains 40% of California. The water from Shasta and Folsom and Oroville go through the Delta before getting pumped down south. And with all the levees and all that, you've done the salinity intrusion exercise. It's kind of the heart of California's water system. And these pumping plants are fascinating. There's two of them, one for the State Water Project and one for the Central Valley Project. They have the same format. We're going to dam up water. When we want to deliver it, we'll release it, go to the Delta, we'll pump it out and send it down south. And this is the Harvey O. Banks pumping station. They just basically dug some deep trenches to encourage the water to come in, installed their pumps, and those pumps pump up the water about 280 feet up, and then it's gravity fed for hundreds of miles along. You can see it along Highway 5, along the Central Valley. It's really kind of pretty when you look at it like that, but it's an incredible engineering feat. The slope of this canal is something on the order of a foot or two drop per mile. That's all you need to move water. And so that's why in places when the land subsides at all, it really can interrupt the flow of the water in these canals. As we get into the Delta more, this map will be more important. And I'm going to ask you to be able to plot the location of the proposed California water fix. You know, those pipelines that they want to put into the Delta. For a long time, for decades and decades, there's been talk about, instead of having the water released from Shasta and Oroville and go down the Sacramento River and into the Delta and then pumped out of these major pumping stations, reversing the flow, mixing with salty water and all those problems, there's always been talk about taking the water out of the Sacramento River and making a peripheral canal around the Delta and having it delivered to the pumping stations, and that way not interrupting the natural flows. That was called the peripheral canal, and that got defeated in the 80s. And the idea has resurrected more recently by taking water out of the Sacramento River, putting it in pipelines, and delivering it directly to these pumping stations, and thereby bypassing the Delta system. Very controversial move. There's a lot of arguments for and against it. We'll get into that a little bit more in the Delta unit. For now, and we've made this point before about storing water in groundwater versus dams, this is a nice figure. It's not that nice, but it's factual, showing the cumulative storage capacity over time in California. And now we can store, it looks like up to, estimates vary, it looks like we can store up to 5 million acre feet of water in all these different reservoirs that have been put in. And this just, again, to put into context what the importance or the wisdom of building a couple more dams, and what effect would that have on our overall system. And I do have an exercise for you to do with dams that I think is kind of interesting. I send you over to this Department of Water Resources Water Management Planning tool. Just a map. It's just a GIS interactive map. You can play around with the different layers in this map. It's kind of interesting. I like to look at the groundwater basins. These are mapped groundwater basins. And these are the basins of groundwater that are critically overdrafted. You can see down south, we're just pumping out more groundwater than is recharging, and they're overdrafted, and the water table's sinking. But for this exercise, I wanted you to take a look at just the California jurisdictional dams. I don't know why they're not popping it. Oh, here we go. There's a lot of them, and this is just the California ones. For instance, Shasta Dam is not on here because that is a federal dam. So here's Lake Shasta, and that dam there is not on this map because it is, again, only the California dams. And I think the same thing is true for Folsom Lake, and Folsom Dam is not on here. So, but I ask you to kind of get some data off these. Each dam has its own little story to tell about its when it was built, how it's built, and what capacity that it has. But, you know, it's just kind of eye-opening to see that we basically dammed all the rivers we can dam. And there's a dearth of dams up here because those are wild and scenic designated, and it doesn't look like we're going to be touching that water, and probably you might think that's a good thing. So I think that's all I wanted to cover. Oh yes, and at the end of the lecture here, I just have this is a very good fact sheet about California water systems. Kind of the big picture, how much rain we get and where does it go, and the different delivery systems. I just think it's, again, there's books and volumes written about this stuff, but if you got most of this fact sheet, and if you were able to identify features on this weird looking map, like, oh yeah, that's Shasta Lake, that's the Kern-Frank Canal, that's a federal project, oh, that's LA's Owens Valley Aqueduct when they secretly bought all the land around in Owens Valley and got the water rights, that kind of stuff. Zooming in a little bit here, it's important. This is the Delta, and there is the federal pumping plant, and this is the Harvey Banks pumping plant, and versus the other pumping plant for the federal project in the Delta Mendota Canal. Just an awareness of these features. When we had an in-class exam, that was kind of how I covered this unit. It just said, here's a map, plot these things. And so for the final in this class, I'll probably do the same thing on the timed exam, just so you know. And just by doing the studying of these features and being able to, you know, go from a map like this to this, I think that's a pretty good orientation to California's water system.